Hi, this is a course on feature engineering, and today we are going to look at fixed width binning. So we are going to transform a continuous numerical variable into uh, bins of fixed width. Okay, so here we are loading a bunch of libraries to generate the data as well as to process the data. These are covered in a bit more detail in the previous video, so you can watch them. And here we are setting some parameters for the plotting. Okay, so here we are generating the data. Now let's say we have customer data and we have the number of months the customer is with us. Now these customers are, let's say they are with the company anywhere between 0 to 120 months. So we have this 2-column data. Now there are a couple of scenarios why we might want to apply this binning method to this months. Now let's say we are building a recommender system or maybe a customer churn predictive model. Now depending on how long the customers are with us, we might be offering them some discounts. So those who are getting the discounts might stay with the company longer or might buy the new product we are offering. Now the way we offer the discount, let's say every 18 months we offer some discount. So if the customer is with us for 18 months, we offer some level of discount. Then between 18 to 36 months, we offer another level of discount, right? So we want to be able to inform the machine learning model that using an engineered feature. So here what we are going to do is, here we have defined a variable called bin width is equal to 18. Now we are going to transform the data to this format. So if the customer is with the company between 0 to 18 months, we transform it to 1. If it is between 90 to 36 to 2, then 37 to 54 to 3, and so on, right? So here we have the data in months. Now there are a couple of different ways we can do. We can use the floor method or ceil method from NumPy. Now if we use the floor method, the starting value would be from 0, whereas if we use ceil, the starting value would be from 1. So here we are simply calling the raw feature value and we are dividing with the bin width which we choose, and then we are applying either the floor or ceil method. So when we apply the floor, the index starts from 0 and our feature is converted into this bin number based on the bin width. Whereas this one, using the ceil method, the index starts from 1. Okay. So here we are just plotting the raw feature as well as the transformed feature. So here we have the histogram of the number of months. Now we have somewhat uniformly distributed. So for example, we have 50 customers who are between, let's say, 0 to 5 months, and also 50 customers, let's say they are also 60 customer between 115 to 120, like that, right? Now this is the transformed variable. So we have transformed these values between 0 to 120 into the values between 1 to 6. Okay, starting from 0, and here we have the number of customers. Okay. Now the other way to do that is defining the number of bins. Okay. So rather than choosing the bin width, here we are choosing the number of bins. Now this is our data. So the minimum value is 0, maximum value is 120. So if we are choosing the number of bins as 5, that's going to give us a bin width of 24. Okay. Now same as before, once we find out the bin width, either we can use the bin width along with this floor or ceil functions, or we can use the cut function from the pandas. Okay. Now the cut function works a couple of different ways. So here we are providing our raw feature value and then specifying how many bins we want to divide this data into. Now if we set this label as false, it will return an integer index. So this variable is going to be months bin cut. Now that is this variable. So the index starts from 0 and it returns this integer value. Now if we call the same function without this labels is equal to false, so we are essentially enabling the label. Instead of this integer, it will return the boundaries, the bin boundaries. Okay, for example, this value 50, it's between 48 to 72 and its bin number 2. Now this value 4, this value belongs to the bin of boundaries 96 and 120, and that bin number is 4. Okay, now to the cut function, we can also provide the bin boundaries explicitly. Now these don't necessarily have to be equally spaced, but in this case, because we are transforming the feature to have fixed bin width, we are explicitly providing the bin boundaries with equal spacing. So this will also return the bin boundaries. Now we don't use these as features in the machine learning. Now we can use any one of these 3 features as a feature to train the models. Now whether the index start from 0 or start from 1, it will not have any effect on the model. Okay. All right. Again, the same thing. This is our raw data, which we saw before. And after we transform the data into bins, this is how it looks like. Okay. That's all for today. Thank you very much.